Hello 108 class, Mr. McHugh back here with you on page 2. Going to keep continuing working on section 9.2 in the quadratic formula, and we're finally going to show how to use this quadratic formula that we went through the theory of how it was generated on the last page 1 of our video. Okay, so what's nice now is you have a quadratic formula. You're going to write it down in your reference sheet. Now you take example 1 and it says 6x squared minus 5x minus 4 equals 0. Solve for x. Okay, now here's what's going on. In general, here's your xy axis, here's your x, here's your y. Quadratic equations form parabolas that go something like this, make a bowl shaped, okay? Where they cross the x-axis is called the roots or the solutions, and that's what we're finding. That's when S says, I've said this before in my videos, when you see the 0 over here, that's really the y variable. It's set equal to 0 because when on the y-axis, where is 0? Right there at the origin. Okay, so here's 1, here's 2, you know the drill. Right here's 0 on the y, you are on the x-axis, aka y equals 0. So we're going to find sometimes it crosses 2 times, it could cross exactly once, and sometimes the parabolas will never cross. Okay, so those are the 3 options: 2 solutions or roots, 1 or 0. Okay, and so all you're going to do now is you're going to be disciplined and following this plug and chug technique. Number 1, identify ax squared plus bx plus c. Identify the coefficients in front of the x squared, in front of the x, and the constant all by itself as a, b, or c. I like to, and this is to help train your eyes to look at the equation, write down a, b, and c, and then you're done looking here. So you accurately got the values, and then you're going to write down the quadratic equation. Now, I encourage you to do this, okay? Please. I see students doing this in high school, and they do a problem like this, and they show barely any work. They don't use the equal signs. They don't write the equation, the formula. They don't use the parentheses. They don't substitute in right, and they get the answer wrong. Okay, you don't want to go down that path because you know the drill. My math lab is going to give you the red X, and you're going to get frustrated. Be neat and organized, and you will be able to find any arithmetic errors. This is not even algebra. Okay, so here we go. You got the drill. I like to use my version of it with the negative b divided by 2a. Remember, that's the line of symmetry, and simply start plugging in. B is a negative 5. There it is again. A is 6. C is 4. Substitute in. Okay? Now, once you've substituted in correctly, you're now in arithmetic mode. Watch the details. Negative times a negative, positive. 2 times 6, 12. You get the drill. Plus or minus. Negative 5 squared, 25, plus, this turns out to be a positive 96. Where'd that come from? Negative times a negative is a positive. 25 plus 96, 121. Square root of 121 happens to be a perfect square root. That's where the 11 twelfths come in. So you get 5 twelfths plus or minus 11 twelfths. Here at this stage, and this is why I like using it this way, when you use the other version, you'll see you've got, I see students making a mistake with the old version. I'll just leave it at that. And it's nothing wrong using it, just that you got to watch the details. So for me, I like this format because now you got 5 twelfths. That's the line of symmetry on the x. You're going to go plus or minus 11 twelfths. So break it apart. 5 twelfths plus 11 twelfths, 5 twelfths minus 11 twelfths. Work your fractions. They don't go away. 5 plus 11, 16 twelfths. 5 minus 11, negative 6 halves, which is negative 1 half, and this reduces down to 4/3, and there you go. Okay, so once you get the hang of it, you do a couple like that, you'll get a process going. I strongly encourage you to follow my tips. Write it down. Plug in correctly. Use parentheses. Replace the A, B, and the C with parentheses. Substitute the exact value in. Then do your plug and chug and watch your math. Okay. Got time, we can do another one here. Here's example 2, and what was nice about the other one, it was already in standard form. Remember, ax squared plus bx plus c equals 0. You look at number 2 and you go, oh no, there's no 0. What am I supposed to do? Okay, move everything all over to the left hand side. Will that produce a 0 for you? Sure. Minus 8x on both sides, add 1 to both sides of the equation, and boom, there's the 0. Now, do you have an A, B, and C coefficients? Yes. 4, negative 8, 1. Write them down. Now you're going to go ahead and write the equation. Now you're going to substitute in correctly. Okay. And you can see this. You know, this takes a little bit of work. No big deal. Because when you're neat and accurate, then that's where you're going to produce correct answers. Okay, now you can kind of see here and follow this. Negative times a negative is a positive. 8 divided by 2 times 4 is 8, so 8 divided by 8 produces the 1. Okay, what's the nitty-gritty details? What's negative 8 squared? 64. What's negative 4 times 1? Negative 16. 64 minus 16, 48. Square root of 48. Oh, not a perfect square. Nitty-gritty detail work. What do you do with it? Sorry, I'm getting all fired up here. Break it down into what? Square root of 16 times the square root of 3. Square root of 16 is what? 4 times the square root of 3. That's what goes in here. Okay, so now you've got 1 plus or minus 4 times the square root of 3 divided by 8. Okay, and I took 4 divided by 8 and made it 1/2. That's where you don't put the 1 up there, but that's there. Now, MyMathLab, they want to see 1 plus square root of 3 divided by 2, comma. It's a shame they don't have this plus or minus because it's kind of a pain. 1 minus the square root of 3 divided by 2. Oh, God, take that away. Okay, not those, for heaven's sake. The bracket. Okay, now, there's your answer. Notice it's in 2 separate solutions. Notice there are no decimal numbers in here. Do not go to your calculator and push the fast calculate button on here. You've got to leave these. This is considered more accurate form because the square root of 3 is an irrational number and you cannot write it out in decimal. Now, for us, in practical purposes, you might say, yeah, but for mathematicians, you need to show the radical sign. Okay, hey, we've done it. We're cruising here on quadratic formula, so Mr. McHugh gonna say that's about it here for now for page 2, and I will see you for page 3. Okay, take care. Bye.